Hi, in this video I would like to go over the Python implementation of the algorithm that is proposed in this article. The idea is to generate a target power spectral density function that is compatible with a target response spectrum and the expected stroke motion duration. So when we need a target PSD, when we generate input motions for dynamic time history analysis, we usually focus on the match between the record response spectrum and the target spectrum, something like this. Let's say that this is our target spectrum. We want our records to have a response spectrum that closely match that target. However, for nuclear applications, the NRC requires in SRP 3.7.1 that the motions also comply with a minimum power spectral density. And the way to perform this check is by comparison with a target PSD function. The problem is that the current methodology suggested in SRP 3.7.1 to generate these target PSD functions does not account for the influence of strong motion duration. And as you can see in this figure that comes from the article, the proposed algorithm generates for the same target response spectrum different target PSD functions depending on the expected strong motion duration. So the theory and details of the algorithm are very well detailed in the article that, by the way, is open access. So in this video I will rather focus on how to use the Python implementation that is provided. Alright, when you download the code from GitHub, this is what you get. So basically just three files. One is the module that contains all the required functions, one file with an example, and a text file that will be used as an input file for the example. So this is the example file. The first thing is to import the DD target PSD function. You see that I'm importing two functions here. They both do the same, but this one, the DDD target MP, use multiprocessing, so it can be significantly more efficient depending on where you are running the code. So for the function, when you call the function here, you need to specify the file name. This is the name of the file that contains the target response spectrum. The file shall contain two columns, the first column with the frequencies and the second column with the spectral amplitudes in units of gravity. You need to specify the SD575. This is the target significant duration in seconds that for this example we specify as 9 seconds. And then you specify the target spectrum name. This is just a string that will be used to name the output files. All other parameters are optional. F1 and F2 define the frequency range to match the target response spectrum. This is the allowable error for the match of the target response spectrum. This is the number of records that will be used to generate the final target PSD from the target Fourier amplitude spectrum. Plots is used to turn on or off the plots. So let's run this. So the way the algorithm works is by first constructing a target FAS, and then this target FAS is used to generate the target PSD function. At the end, the code will show you what was the mean strong motion duration for in this case, 1000 records used to generate the target PSD, so it can be compared with the target duration. In this case, the mean was 9 and the target was 9 seconds also. So the function returns the target FAS, the target PSD, and the frequency where they were estimated. It also generates a plot, like a figure, with this information here, and an output text file with the frequency, the target PSD, and the target FAS. Well, that's it. I hope this video helps. If you have any question, just send me an email.